Hello everyone. For today's discussion, we are going to learn about reverse linked list. To begin with, what is a linked list? So linked list is a data structure made of nodes where each node contains data and a reference to the next node in the sequence. And singly linked list it only points forward, like in the picture. Then why do we need to reverse a linked list? There are several reasons, but the main things are because first, to manipulate data order for various applications such as undo operations, reversing paths, and algorithms that require reverse sequences. And it is very useful for memory-efficient data storage when we need to access from both ends. So in a single linked list, each node points to the next one. So we have 4 nodes in total, but we are going to have 3 nodes tracking the status. So the singly linked list is going to look like this. But our goal is to reverse these pointers like this. So let's dive into step-by-step explanation. So right now we have a current node pointing to 1, which is the head. The first thing that we have to do is to save the next node temporarily. So we're going to move our current, which is 2, and then we're going to reverse the next pointer to point to the previous. So we're going to point this to none, and then we're going to update the label. So right now our current is 2, and our previous is 1, and the next node is 3. Like we did before, we're going to save the next node temporarily, which is 3, and then we're going to reverse the next pointer to point to the previous. So we're going to update our pointer, and then we are going to move previous and current to 1 step forward to continue the process. So we need to update our label. Our previous is going to be 2, and the next node is going to be 4. And we're going to do the same thing. So move it, update the pointer, and then update the label. And then lastly, we're going to put our current node to none. And then we're going to update our pointer and the label. So right now, once the loop finishes, the previous, which is here, will point to the new head of the list, which is 4. So this is going to be the new head. And the current, which is here, will be none. So we have to remember what the final new head is. Okay, now let's dive into coding according to the explanation before. So we have a function called a reverse linked list. So the first step we have to do is to initialize 2 pointers. So the first one was previous, which is going to be none, and the current is going to be the head, which is the starting point. And we need a while loop. So while loop is going to iterate through each node in the list until the current becomes none. So while current is not none, the next node will be the current next. And what does this mean? The first step inside the loop is to temporarily save the next node, which is current.next, in a variable called next node. And now we're going to reverse the next pointer of the current node to point back to the previous node. So the current next is going to be previous. After reversing the pointer, we will move both pointer previous and current 1 step forward. So we're going to say previous equals current, and we're going to move the current node to the next node. Then what are we going to return? So once we reach the end of the list and current becomes none, previous will be pointing to the new head of the reverse list. So instead of returning the head, we're going to return the previous, which will be the new head. Before we end our discussion, what are the key takeaways? So first, reversing a singly linked list requires updating each node's pointer to point backwards. And the most important thing is, the process involves a linear traversal, making it an O(n) operation. And lastly, this technique is commonly used in algorithms requiring list order manipulation. Thank you for listening.